When I first started teaching math, I would teach my sixth graders the rules when it came to multiplying integers. So I would make sure that they wrote down in their notebook that a negative number times a negative number equals a positive, and that a negative number times a positive number equals a negative number. And so I felt really good about them copying those notes down into their notebook, but quickly realized that the rules don't always stick and that you have to show the reason why some of these rules are the way they are. It's not someone making up rules to confuse all of our young mathematicians, but as with a lot of things in math, there's a pattern to show why it works. So to help me explain this, I have with me my 9-year-old son, Trevor. Say hi, Trevor.
Hi.
And I just want to make sure, have you ever been taught how to multiply negative numbers?
Not yet.
Okay, so we're going to go through a process to see if you can develop and understand the rules when you're dividing and multiplying integers or positive and negative numbers. So to start off, I'm going to give you a problem that you already know how to do, which is 5 times 2. What's 5 times 2?
10.
Okay. And what about 4 times 2?
8, sorry.
And what about 3 times 2?
6.
And what about 2 times 2?
4.
And I bet you can guess that the next problem is
1 times
1 times 2, which is?
2.
And what is the next problem in my pattern here? 5, 4, 3, 2, 1.
0 times 2.
And 0 times 2 is?
0.
And then what's my next problem going to be?
Negative 1 times 2.
And what do you notice about the answers on the right-hand side? 10, 8,
They all go
6,
down by 2.
4, 2, 0. So what's the next answer going to be?
Negative 2.
Negative 2. You just came up with the rule of a negative times a positive equals a negative. It's not a made-up rule. It follows a pattern. So now that you know that a negative times a positive equals a negative, we're ready to go on to another rule. Okay?
Okay.
So now that we know a negative number times a positive number equals a negative, we can show another rule with a pattern. So starting with negative 2 times 5. What's that answer?
Negative 10.
And negative 2 times 4.
Negative 8.
Negative 2 times 3.
Negative 6.
Negative 2 times 2.
Negative 4.
Negative 2 times, what's the next one in my pattern here?
Negative 2 times 1.
5, 4, 3, 2. So the next one is 1. You're right. What's negative 2 times 1?
Negative 2.
And the next problem will be negative 2,
times 0.
which is?
0.
And what pattern do you notice with the answers? Negative 10, negative 8, negative 6, negative 4, negative 2, 0. What are they increasing by each time?
2.
So the next answer in this pattern is?
Positive 2.
Positive 2. So we have negative 2 times, and what's the next number in this pattern here?
Negative 1.
Negative 1 equals 2. So what we have here is a negative 2 times a negative 1 equaling a positive number. So there's our next rule, which is a negative times a negative equals a positive. So the next time you think about telling students to remember a rule when it comes to mathematical processes, don't start with the rule, but use a pattern to help them discover why those rules exist.